In this example, we're going to work the 2018 AP Calculus AB free response question number 1. As this is the first question on the FRQ, this one's going to be calculator. Let's read the prompt, see if we can answer parts A, B, C, and D, and then I'll show you the work on the calculator as well. So here for number 1, it says people enter a line for an escalator at a rate modeled by the function r, given by r of t. So that's a rate, and r of t is right here. And this piece is only valid from 0 to 300 for time. This other part, the rate that people enter, is 0 for any time greater than 300. So people aren't entering the line is what that means after 300. Here we're told that r at t is measured in people per second. T, of course, would be measured in seconds. As people get on the escalator, they also exit the line at a constant rate of 0.7 people per second. And then also there's an initial condition here. There's 20 people in line at time 0. So what we have here is we have a rate of increase and also a rate of decrease. And we also have an initial condition with some people in line at that time, at time 0. We're going to have to be very careful about the wording of each particular item, and that wording is going to help us to figure out what the solution path might be. So let's see if we can work through each part. Part A asks us how many people enter the line for the escalator during the time interval 0 to 300. Notice this does not ask us how many people are in line for the escalator during that time or at a specific time. Instead, this asks us for an amount of change. How many people enter the line is the amount of change from time 0 to 300. If we want to represent this with an amount of change, we need an integral. And we're going to take the integral from 0 to 300 of the rate function. That's going to give us our amount of change. So we'll write r of t dt. And we want to see what that's equal to. It might actually be equal to here. We'll see. Now, what you're going to want to do with this one is you're going to want to type that r of t equation into your calculator. So I've already done that. Take a moment to pause the video and see if you can type this in. You'll notice that r of t is replaced with y1 in your calculator. That's what your calculator understands. And you'll also notice that the t is x. Your calculator works best with x's and y's in the function mode, and you'll want to use that. Point for the, or a main point here for the AP exam is only write down what they give you in the problem. Don't write down what you're doing in the calculator. You are allowed to type this in your calculator using y's and x's, do your work, and then write the answer down. You also need to show what you're doing though, which is what we did with the integral on the left-hand side of the equal sign. So without further ado, let's go ahead and evaluate this integral. You're going to want to go back to your home screen, and then you're going to hit Math, and it's number 9, FNINT. You can either hit number 9 or you can cursor until you're on the 9 and hit enter. The lower limit is 0. The upper limit is 300. And here we've already entered this in y sub 1. So you can re-enter it again into this position right here, the entire equation if you wanted to, but I wouldn't. Okay, what I would do is I would go to alpha F4. There's your shortcut menu and hit enter. Or if you want, let's see here, get out of this. If you want, some calculators don't have that shortcut menu, so let me show you a different way of getting there. Hit your vars key, which is just below your cursor pad, and you can cursor 1 to the right to get your y variables, hit enter, and hit enter again. So that's another way of getting y sub 1. And all that's going to do is put the expression that you entered in right here. Makes it nice and easy. The variable of differentiation is x. We entered x into our y sub 1, so we'll want to use that again. You'll want to use r of t and dt for your actual work when you write it down on your paper. So we'll hit enter here. We'll let the calculator do the work, and we get 270. So that's not how many people are in line at time 300. To figure that out, we need to take into account the initial amount and also how many people have left the line. However, the question's just asking you for how many people have entered the line from 0 to 300, and that's it. It's 270. You can write a little sentence here if you wanted to. You could say 270 people have entered the line from 0 to 300 if you wanted to be more explicit about it. However, the points for this, you'll get 1 point for showing the integral. So that's this part right here on the left-hand side of the equal sign. You do have to write down what you're finding, and then you can ask the calculator to go ahead and figure that out. You don't need to show any of the steps that you did in the calculator. You're allowed just to type that in and hit enter. And then you'll get another point for the answer, which is 270. So if your setup is correct, you get 1 point on the left. And if you made a mistake in your calculator calculating it, you won't earn the point for the answer, but you'll still get a point for the setup. So make sure that you're trying to do both, obviously. And if one doesn't work, then you'll still get points, perhaps. So 2 points for part A, and we're moving on to part B here. Part B says during the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time t is equal to 300? So this question is not asking us for amount of change. Instead, we have to compare a few things. And we might even want to write an expression here for the amount of people at any time t. However, this does ask us for a specific time t is equal to 300. So let's go ahead and write down an expression for that. Well, what we want to do here is we want to take into account the initial amount, right? At time 0, there's people in line already. So that would be 20. Then we're going to add the amount of change for the increase, which is from 0 to 300, r of t dt. Luckily, we've already found that. So this 20 represents, and you don't have to write this down, I'm just trying to be real specific here. This 20 represents the initial amount, and then the 0 to 300 with the integral of rt dt represents the amount of increase. And we still have to take into account the amount of decrease. So we're going to do minus. Now, if we look above, it says that the rate of decrease at a constant rate of 0.7 people per second. So I have to take 0.7 and multiply that by how many seconds have gone by. So that's going to give us our amount of decrease. We don't need an integral for that one because we have a constant rate. So that one's okay. What we want to do then is we want to actually compute this and see if we can figure this out. So from part A, you can go ahead and use what you did in part A here. We found that to be 270 for the amount of people who have entered the line. And then we want to do 0.7 times 300, which is 210, and we have to subtract that because that's how many people have left the line over that time period. And so if we do this arithmetic here, we're going to wind up with 80. You could just leave this here actually as your final answer. That would be great. You don't have to actually do the math here for that to figure out the fully simplified answer, but I'm going to write down 80 here just so you know what the fully simplified answer would be. So how many points will you get for this one? There's going to be 2. Number 1, you have to consider the rate out. So that's this piece right here, the amount of decrease. And then your answer, of course, is what you're going to get also for points. So your second point is going to come from the actual answer, which could be that expression boxed in or 80. Any numerical expression equal to 80 will earn you that last point. 2 points for that one. Let's move on to part C. Part C is also actually a 2-pointer, or excuse me, it's a 1-pointer. So let's see if we can figure this one out. It says for t is greater than 300, what is the first time t that there are no people in line for the escalator? Okay, so let's see here. From 0 to 300, or let's say at 300, how about that? Which is from part B, by the way. So we could say at t is equal to 300, there are 80 people in line. I'm just writing this down so that you can see my thought process here. You don't have to write this part down, but you could if you wanted to. And if we look at the expression, go all the way back to the prompt here, we can see here that r at t is 0 for any time greater than 300. So people are not entering the line at that point. Instead, the only thing that's happening is the amount of people is decreasing. So what we want to do is we want to take 80 and we want to divide that by 0.7. 7. If we divide 80 by 0.7, that gives us approximately 114.286, and that's going to be in seconds. So that tells us that it's going to take 114.286 seconds for those 80 people to leave. Now, we want to be very careful with this and figure out exactly what our answer should be. So I like to go ahead and reread this one. It says, what is the first time t that there are no people in line for the escalator? All right. Well, we found out from 300, it's going to take another 114 seconds and a little bit for there to be no people in line. So what we actually want to do for our final answer here, because t is given from time is equal to t is equal to 0, we want to actually add these two values together to get our final t value here. So you're going to wind up with a final answer of 414.286, and that's seconds. So that's the actual t value when there are no people in line for the escalator. You'll get a point here for this piece. You could write that, or you could write the final answer. It does not ask you for a unit, so if you just wrote the numerical answer, 414.286, you should get 1 point. And again, that's 1 point, and it's basically 1 point for your answer. So we've got 5 points so far. That means the last part here, part D, is going to be worth 4 points. Okay, let's read this one and see if we can figure out what to do. So it says for 0 to 300, at what time t is the number of people in line a minimum? So right away, in my head, I'm thinking EVT. The reason why I'm thinking EVT is we're trying to find a minimum or a maximum over an interval. So if I even started to build this table, I'm going to do my time t, and then we're gonna have to actually introduce a new function here. So we're gonna say let p of t equal the number of people in line. Okay, and so we know we have to check 0, and we know we have to check 300. The minimum could occur at the beginning. There's only 20 people there, or it could occur at the end. Who knows? Let's keep reading on. It says to the nearest whole number. So this is a case where the question tells us what to round to, so we don't need to round that final answer to the nearest third position after the decimal. We actually want to pay attention to the instructions in each individual question. And if we're asked to round to a different place value than the third position after the decimal, we need to go ahead and do that. And then it says, find the number of people in line at this time t. Okay, so we need to find a couple things. We need to find the number of people in line, and we need to find that time t when the number of people in line is at a minimum. So we need to find that time t, and we also need to find the actual number of people. The justification for our answer is going to actually be our work. We really don't have to write too much for this one. We will write a sentence here at the end, but what we want to do is we want to actually just show that table on the left-hand side. And that table, according to the EVT, we'll be able to tell what's the minimum. We'll just look at the lowest number in the right-hand column, P of t. So let's see if we can represent P of t. And this comes from a previous part of this question. So previously we said if we want the actual number of people in line, we have to take the initial amount, and we have to add the amount of people that have increased. Now this one's a little different because we have to introduce a t right here because we don't know what that t value is. And then we'll use a different variable here for r. So we'll use r of x dx. You just have to have a different variable than the upper limit. It's a real funky t here. Let me see if I can draw you a better one. All right, there we go. And then let's see here. So we have to subtract 0.7 times t, whatever that t value is. In the previous part, I think that was part B, the t value was just 300 because we were wondering about 300. The nice thing about this expression for P of t is we can make t whatever we want, and that will give us the amount of people in line at that time t. What we need to do here actually is we want to use our knowledge of the derivative. So we're going to take the derivative here and actually set the derivative equal to 0, and that'll give us possible values of t where there could be a minimum or even a maximum for that matter. So the EVT says you need to investigate the endpoints, those t values of 0 and 300, and any value for t that causes the first derivative to be 0 or makes it undefined. So let's take the derivative here of p, and we've got the derivative of 20 is 0. So that's the first part right there. The derivative of the second part of this one is going to actually be the fundamental theorem of calculus, which says take that upper limit, sub that in. So that's going to be r of t, and then multiply by the derivative of the upper limit. Well, the derivative of just t is 1, so we actually don't have to worry about it too much. And then the derivative of negative 0.7t is negative 0.7. So there's your derivative work. And what we're going to do here is we're going to set this equal to 0. So we've got 0 is equal to, and then we have r of t minus 0.7. Now there's two ways of going about this. So you can enter this in your calculator as y sub 1 minus 0.7 in y sub 2. So you could do that, or what might be even easier is to just do add 0.7 to each side, and we're going to see where r of t is equal to 0.7. So a couple different ways of doing it. Either way is okay. Let's go ahead and take my approach here. And what we'll do then is we're actually going to turn this one off. We don't need that. So what you can do is cursor over the equal sign and hit enter. And then in this one right here, actually that's wrong. Sorry, that would be for the other method. Let's keep it on. Scratch that, disregard. And we want that r of t, which is in y sub 1, we want that to be equal to 0.7. Now, before we do this, we have to adjust our window a little bit. And so let's take a look at, if we hit zoom 6 here, we might not see much. And one of the reasons is our x min should actually be 0. That's our t value. And then our interval here gives us another t value of 300. That's our maximum t value. And the minimum, it says, in the prompt, it said that there's always people in line from 0 to 300. So our y min, that's going to be our output. That's the number of people in line, could be 0. And it's up to you what you want to make the y max here. If we want to see most of the function, I would guess maybe 100 maybe, and you can always go back and adjust that. So once again, if you need to pause the video there, go ahead and do that. And then all I'm going to do now is just hit the graph button to the upper right hand of your cursor pad there, and we're going to see what this thing looks like. Now, see, my y value was pretty messed up, so I'm going to go back to the window, and I'm going to make that something less. So let's see here. I'm going to make that maybe 10 and see what happens there. Okay. That's a little better. It seems like maybe 1, 2, 3, 4 would be a little bit better here. And we're actually looking at the rate here. Whoops, let me hit the window, and we're going to go with a y max of 4. This will just help us to see things a little bit better. So my bad on that. The rate would be what we're looking at here. So the blue graph is r of t, which is a rate of increase, and then that constant rate, that level red line, is the rate of decrease. So we want to know when those two are equal. And let's take a look here and try to find this. We've got to calculate an intersection of these two. So I'm going to do second trace, which is my calculate menu, and I'm going to go down to number 5. The calculator will prompt you. We can find the one on the right if you want first. So we'll hit enter. That's our first curve. And then our second curve is the one in red. Hit enter. And then it says to guess, and you could probably just hit enter, but I'm going to go ahead and move the cursor as close as I can to that intersection point and hit enter. So we've got 166.575. So that'll go over here, 166.575. Okay. So there could be a maximum or a minimum there. Let's find the other intersection point. So we'll do second calculate. We'll hit number 5. And then first curve, that's going to be the blue one right here. So I'll hit enter. And the second curve, I'll hit enter. And I'm going to guess, you can keep hitting the cursor if you want, and you'll move over, or you can actually just type the x value that you think is closest, like maybe 50 or 30 or something like that. So you could hit enter there, and it'll find the intersection as 33.013. All right, so lots of work here for this last one. Once again, it's a 4-point question, so there's going to be some stuff going on here. How many points would you get if you just did that? Well, you would get 2 points. You'd get a point here for considering R at t minus 0.7 as your overall rate. And then you get another point for identifying 33.013 as one of your t values here, okay? Now, we can start filling in the table because there's 2 more points to be had here. So there's your answer and your justification. So our justification is going to be looking at these p of t values, and then our answer we're gonna find pretty quickly here. So at time 0, the prompt says there's 20 people there, and we're good there. And for 300, we can go back to a previous part, and we find at 300 here, that's part B, the amount of people in line is 80. So we don't have to redo that work. We've already done that in this problem. We're good to go. Now we need to figure out those other ones where t is 33.013 and 166.575. How are we going to do that? Well, we're going to look at this expression for p of t right here. Remember, p of t is the number of people in line, and that's what we're looking to find the minimum or maximum of. So what we want to do is we want to type this into our calculator, and we want to use a t value of 33.013 first, and then the other one will come next. So let's try that. I'm going to go back to my calculator here, and we're going to type in 20, and then we'll do math number 9. That's our integral from 0 to. Now the upper limit here is going to be 33.013, and then we'll do y sub 1. That's where my r of t is. So that's our amount of increase, and then I have to do minus 0.7 times 33.013. Okay, and if I hit enter, I get 3.803. So that's the amount of people in line according to this model at time 33. Well, that's lower than 20, so we're on the right track here. You do definitely want to try this for the other one, because that one could be a little bit lower than 3. Maybe not, we'll see. So what I'm just going to do here is I'm going to hit second enter, which is going to bring my entry down. And you can type this whole thing again if you want, but I like doing this because all I have to do now, is just replace that upper limit with 166.575. And then I'm going to come to the right, and the only other t value here is the 33. And so I'm going to replace that with 166.575. So it makes it a little bit easier. And then I'm going to hit enter. I'm going to get that value there. Now that value is 158.070. That's supposed to be an 8 right there. Okay, so our calculator work is done. With a lot of thinking and a lot of work here, we've successfully used the EVT, the extreme values theorem here, to indicate that the lowest amount of people, if we look at our P of T, we have 20, 3.8, 03, 158 and change, and then 80. So our lowest amount is right here. So what we're going to do when we write our answer, we're going to say, by the EVT, the minimum amount of people in line. I'm just rereading the question here, so I'm looking at this line right here. I'm kind of using what they've written down to write my answer. So by the EVT, the minimum amount of people is 4. We want to round to the nearest whole number, which occurs at t is equal to 33.013, and that's seconds. So let's recap just once again the grading for this. This one's a 4-pointer. You're going to get a point for basically considering this fact right here for the difference between the rates, and you're going to get a point for considering that's equal to 0. That is important for the EVT. Also, the endpoints are. And you get another point for identifying 33.013. That's right over here. Oops. So that's this piece right here. So you get a point for identifying that. And you get a point for your answer, or answers, I should say. So you have 2 answers. One answer is the number of people is 4, rounded correctly. And then the other answer has to be this piece right here, when that occurs, right? We can read that in the prompt for part D. And then the other point is for your justification. So our justification could include the EVT, but it's mostly basically this whole table right here. I mean, this whole thing is basically your justification for this piece.